Good morning, students. So today we'll be discussing about IoT network architecture and design. So before I move into the network architecture and design, so in previous two lectures, we were discussing about what is IoT. So the genesis of IoT, how the internet got evolved, and where we are present now. Regarding that, we discussed. Then the factors affecting the performance of IoT. So that also we discussed regarding. So we discussed about the challenges which are being faced by the IoT, scale, the data rate, and many more things. Okay. So in second lecture, we were discussing about some applications of IoT, exactly the benefits of IoT where we can use. Okay. So now we'll move on to the in-depth topic, which is called as IoT network architecture and design. So in this today's session, we need to discuss about what is architecture first thing. Later, what kind of architecture we need to design so that all the challenges of IoT should be overcome. Okay. So regarding that, we'll be having a brief introduction. What is IoT network architecture? How we need to design and all. So in next lecture, we will be discussing two basic kind of IoT architecture exactly. Okay. Later, we'll go for the advanced kind of architecture. Later, there will be a continuous discussion regarding that advanced kind of architecture. Fine. A simple architecture we are calling it as. Fine. So that will cover your first model exactly. Okay. What is architecture exactly? Okay. If I ask you a question, what is architecture? You'll be answering like plan from base, right? Plan from base exactly. If I want to start any project, fine. First, I need to design the modules, right? Okay, like how the project should flow, what should be the inputs for our project, okay, how the logic should be applied, in what places logic should be applied, then on what format data output it should be, okay, right? So this is what we are calling it as the architecture of a project exactly, right? Plan from base, we are calling it as. Okay. Then detailed information about complexity. After planning what I want to achieve or what I want to implement, then what we need to do, we need to get detailed information about the complexity. Means, as I mentioned, in case of a project, okay, what should be the input? I told you, okay. Then when it comes for input, there are a lot many patterns of input we can get, right? Okay, we can provide it for our project exactly. Sometimes the input for our project may be a data, okay, which is available in the server. Sometimes it may be image, sometimes it may be a video, sometimes it may be a audio, right? Or sometimes it may be a sensor-based information, right? Okay, if you are trying to prepare a project which should monitor or which should guide the user regarding the atmosphere, then obviously like humidity sensor we may be using, okay, heat sensor we may be using, okay. After sensing that, whatever the information we are getting, by collecting that, we'll be providing it for a server, okay, which is to provide information like whether the rain is going to happen within 24 hours or not. Okay, so in this case, we need to design lot many things, okay, regarding the input pattern, regarding the logic, how it should be processed in raw data, how it should be transferred for the user, how it should be presented for the user, everything, okay. So regarding all these aspects, we need to design or we need to discuss. So that we are calling it as an architecture. Fine. So we are trying to discuss regarding what? Regarding the IoT network architecture, right? But here, the architecture will be designed by an architect, obviously. Is it right? Okay, a house or a building, okay, whatever I call a building is, okay, so it will be designed by an architect, obviously, like interior, exterior, okay, such type of architectural kind of a building if you want to construct, okay, then we need to be dependent on the architect. So here, we got a two different type of architect. One is for designing the house, one is for designing the stadium, okay. See, the architect who is able to design a house, okay, he may not be able to design a stadium. Okay, the architect who is designing the stadium, he may not be familiar with designing the house. See, logically, if you think, okay, fine, like if he is having a practice, if he spends some time, then obviously the house architect can design stadium, stadium architect can design house exactly. Okay, but suddenly one who is not at all having the experience of designing that, if you provide the job, okay, and if you ask him to finish it within 1 day or 2 days, okay, then he may not be able to complete it, right? Because just observe, the house architecture will be very simple. Is it right? Okay, house architecture will be very simple compared to the stadium architecture. Fine. Stadium means what? It should have a capacity to hold the weight of thousands of people. Okay, along with some furnitures. Is it right? Sitting arrangement and all. Okay, the elevation. Then lot many things are available. Security purpose also we need to observe. Okay, but when it comes for like the stadium, which is covered in acres of land. Okay, for that we are trying to design a plan over there. Okay, but for a house, it will be available within 60/40 or 100 by 100, such type of area. Is it right? Okay. So here, there is a huge gap in designing a house and designing a stadium exactly. So now, what right now we are dependent on that IT network, like information technology network. Okay. So that is not sufficient exactly. Okay. So that IT network we are comparing it for, that IT network architecture we are comparing it for house architecture. Okay, and the IoT architecture we are comparing it for the stadium. Okay, I hope you got the idea, like why we are taking this architect example of house and stadium exactly. IT network, we are considering it as a house architecture. IoT network, we are considering it as a stadium. Means we are trying to design a huge amount of network exactly. Okay, fine, we'll go through. Enterprise IT network architecture has matured yes, it has matured significantly over the past 2 decades and is generally well understood exactly. Okay, so whatever the IT network we are dealing with right now, fine. It is from past 20 years exactly. Okay, so now like what we are calling, it is working fine, no issue. We don't have any issue with IT network, but the same work process, okay, if you are involving it for IoT, then we are facing the problem exactly. Okay, so what we need to do, we need to go for some upgraded version of IT network itself. We will see that how we can do this. It is important to note that while some similarities between IT and IoT architecture do exist, okay, like some existing similarities we are having, okay, for the most part, the challenges and requirements of IoT system are radically different from those of traditional IT network. Okay, although if we are having some functionalities similar in case of IT network and IoT network, okay, although we need to observe some some crucial kind of difference, okay, where we are having between IT and IoT. Okay, the challenges passed by IoT network have driven new architectural models. Okay, the challenges which are posed by your IoT network, okay, which will let us to go through some new architecture exactly. You may ask, what is the difference between IT and IoT exactly? Right? Okay. See, when it comes for okay, when it comes for comparing IT and IoT, the main difference would be what the data. Okay. See, in case of IT, like the information will be available in the server exactly. Is it right? But here, in case of IoT, information will be grabbed from the real world or a real atmosphere exactly. Okay. There, the real-time data will be available in case of IoT. Okay. The process information will be available in the IT exactly. Fine. There is a last mile gap we are calling it as. Okay. Server, obviously, we are dependent on a application server over here in case of IT also, in case of IoT also. But okay, between server and the physical world, okay, there is a lot of network aspects we need to concentrate. Yeah, okay. So that is what the condition, or that is what the difference between the IT and IoT network is. So we'll see, okay, what are the difference we are having. Okay. Drivers behind new network architectures. Okay, the difference between IT and IoT network is much like the difference between a residential architecture and stadium architecture. There is a lot of difference between these two. Okay, let it be. What is the difference between these two? No need to worry about that. Okay, because that is not important. But you should analyze. Okay, like what is IT and what is IoT. That's it. Okay, it has served us well for many years. Okay, They're not well suited for the complex requirements of IoT. Okay, the key difference between IT and IoT is the data. Okay, IT systems are mostly connected with the reliable and continuous support of business application, or else we can consider it as a server. Okay, IoT is all about the data generated by sensors and how the data is used. Okay, remember one thing, see, whatever the information we are grabbing from the sensors, right, the physically mounted sensors in the physical world, okay, they'll be continuously supplying some information. Okay, sometimes it may be useful information, sometimes it may be useless. Okay, doesn't matter exactly. But that information should be processed properly. And one more thing you need to notice, between the application server and the bottom level sensors, whatever we are using, okay, between that, we need to build an very important network over there, trustworthy, important network we need to build over there. That's so that the privacy and the safety of the information should be the mandatory issue over there, remember. Okay, so that we need to provide. Fine. Okay, then only we can go for implementing the IoT network. The essence of IoT architecture does involve, okay, how the data is transported, collected, analyzed, and ultimately acted upon. Okay, so the IT network, okay, what you used to do is, like, it will be available with some information, finally it will be processed, and some result will be generated, that's it. Okay, but here, like, the very important concept would be how data should be transferred between the sensor and the application server. Very important question. First thing. Later, like how the data should be collected. Okay, it is the case of application server exactly. How it should be collected, because we cannot restrict the server like you should use only one sensor. Okay, there will be a lakhs of sensors available or thousands of sensors available. Okay, so your application server must be able to collect all the information properly. Remember this. Okay, then analytics we are calling it as, means, as I mentioned, the sensor used to sense, okay, 24/7. So we may be expecting some kind of information, okay, but maybe sometimes it will not happen. See, the tsunami sensors what we are using in the ocean or the beach level, right? Okay, so daily we'll be getting some information, right? But daily tsunami is not going to happen, right? Okay, sometimes. Okay, so analytics means what? What you are expecting. Yes, you are getting the information, fine, let it be. Okay, that should be continuous. Okay, I agree with that. But out of that only we are concentrating about few portion of the information. Okay, sometimes it may come, sometimes it may not come. Okay, it is not like, oh, 24/7 sensor is sending information, we need to maintain it. No, it will be wastage of your resource. Remember, okay, that should not happen exactly. Because of that, we are using analytics over there. Means whichever the important portions are there, that only will be managed in the network. Rest of all will be vomited from the network. Remember this. Okay. Then, so these are the drivers behind the new network architecture. Okay. Like when we are comparing with the IT architecture with the IoT architecture. Okay. We are going for the new one exactly. Okay. Then description and IoT architecture change required. Okay, so what are the different changes? So total 3 plus 3. Okay, total 6 different changes we are expecting over here. First one is the scale. Number of sensors are more in IoT. IPv4 address space has richer exhaustion and is unable to meet IoT scalability requirements. Okay, so scale can be met only by using IPv6. Okay, as you know, the evolution of this internet protocol. Previously, we had IPv4. Okay, basically, if you want, you can check with your laptop network settings and all. If you are trying to place a manual kind of network, network IP, okay, then there will be some version like IPv4 and IPv6 exactly. Okay, usually we prefer IPv6. Okay, and obtain IP address automatically. Such type of option we are using over there, right? Okay, so using IPv4, the number of accommodation or number of users what we can accommodate will be very less compared to the IPv6. Right now, we are enough with the IPv6 exactly. How we are enough with 64-bit system? Okay, previously we had 32-bit system. Why we are going for 64-bit system? Because we need to achieve the speed. That's it. Okay, we need to achieve the speed. We need to accommodate lots of instruction at a time. Okay, so what we did, we are going for 64-bit system exactly. Okay, same wise here also we need to get upgraded from IPv4 to IPv6 exactly. So this is what the main change we are expecting in our new network architecture. Okay, we'll see that. how it can be resolved and all. Then when it comes for security, okay, second aspect is what security exactly. IoT devices are often physically exposed to the world. Okay, security is required at every level of the IoT network. Each node must be a part of overall security strategy and support device level authentication and link encryption. Okay, fine. This link encryption is very, very essential. Remember this. Okay, and also the device level authentication. Okay, what is this device level authentication? See, in upcoming classes, you'll be getting into know that. Okay, we are having different levels of this IoT architecture in fact. Okay, edge level we call it as, fog level we call it as, mist level we call it as, and cloud level we are calling it as. Okay, there will be different section. Each section is having its own contribution to the network exactly. Remember this. Okay, but in case of this, okay, we need to provide security also. Remember, okay, we need to provide a proper security for our sensors, a proper security for the network routers which are able to send and receive the signals. Okay, otherwise it could be wastage of time and resources exactly. Okay, because we are trying to grab a message like trustworthy information, okay, from our network. So due to some malfunction, okay, due to some unauthorized access, okay, we may not be or we should not get any kind of false result exactly. See, actually, example, one sensor we are having to measure the heat, okay, if it is more than 50 degrees centigrade, then the system should turn off exactly. We work, some manufacturing industry it is, okay, some system we are having, some manufacturing unit we are having. So if its temperature go above the 50 degrees centigrade, then automatically it should be turned off. Okay, feel that if it go above 60 degrees, okay, then the complete system may get crashed, okay, because of heat. Something gets melt over there. Okay, so for that we cannot continuously monitor the thermometer, like based on thermometer we cannot monitor it. Okay, so what we will do, we will deploy some sensor. Okay, who is having the capacity to sense up to 50 centigrade. Okay, after that, if it is there, then it should intimate the system that you should turn off your manufacturing unit. Okay, so here, if anybody is trying to cause some harm to the industry, okay, if we hack that particular sensor and if we just flood the result like 50 as a 40, okay, then 50 to 60 will get increased, but we'll be monitoring it as what, 40 to 50 exactly. Okay, there is a gap of, there is a malfunction of 10 degree exactly. Okay, so it may collapse your complete manufacturing unit over there. So such things should not happen. So security is must be done. Okay. Okay, constrained device, and next will be constrained device and network. What is this constrained device? Fine. See, some restrictions will be available. See, as I mentioned, we are upgrading from IPv4 to IPv6. Okay, presently we are with some working internet, Internet of Things network exactly. So whatever the devices we are using, right? Okay, so that should be utilized in IPv6 network also. Remember, for that, what we need to do, we need to use a procedure called as a tunneling. Okay, in network concept, you are having better knowledge about that. Okay, tunneling means what? IPv6. If you are having a three device, ABC. Okay, you are having a three device, network device ABC. A is IPv6 supported, C is IPv6 supported. Means A and 6 are IPv6 supported, but B is IPv4 supported. Now the thing is, from A to C, I need to transfer some information. Okay, now device A will be generating a information based on IPv6 protocol exactly. Okay, that will be handed to device B exactly. But device B is working in a IPv4 fashion exactly. So here we need to go for a conversion from IPv4 to IPv6 to IPv4 exactly. This conversion we are calling it as tunneling. This process we call it as tunneling. Okay. Then later B should transfer the same information to C, but C is working on IPv6 exactly. Is it right? Now again we need to have a tunneling between IPv4 and IPv6 exactly. Yeah, so that's why we are calling it as constrained device and network. Regarding this also we need to concentrate. Then devices and network constrained by power. Okay, few are constrained by powers. Okay, let it be sometime it may be battery backup device, it may be sometimes like continuous power supply device, it may be, it happens. Okay, our CPU, sorry, our desktop, which is under like continuous power supply kind of device exactly. But our laptop, we have a battery backup exactly, right? So that type of constraint may be available. Then CPU, working speed. Regarding that also, we may be having problem, or we may be having some difference over there. Okay, the memory and link speed. Okay, so these are all what some sort of constraint we are facing. Okay, when we are trying to deploy a network example. Obvious, due to massive scale and large distance network. Okay, is supporting once again. Due to massive scale and longer distances, network is supporting only minimum data rate. Okay, new last mile wireless techniques are needed to support long distance and advanced transport mechanism. Okay, so we call it as a last mile wireless technology. Okay, that I will discuss later. Last mile wireless technology means what? Which is exposed to the physical board. There we are deploying the wireless technique. Okay, but the rest of all the time it will be wired based exactly. Just like okay, so these are all what some changes we need to adopt. Okay, if you want to achieve the efficiency over there. Okay, the massive volume of data generated. Okay, so this is also one of the concept we need to address. Okay, massive amount of volume data will be generated. Since I generate massive amount of data causing network bottlenecks and slow analytics in the cloud. Okay, so data analytics capability need to be distributed throughout the IoT network. Okay, from the edge to the cloud exactly. So as I mentioned, okay, we are having different levels exactly. Okay, the first one we are calling it as the edge. Okay, then mist level, then fog level. Okay, and the cloud level exactly. So what they're trying to say here is, okay, so in the edge level, we'll be having different sensors. Okay, we'll be having different sensors. The job of the sensor will be they'll be sensing the atmosphere, they'll be sensing the environment. They will just start flooding the information to the edge to mist level to fog level to cloud level exactly. Fine. Okay. So now, if these two devices, okay, fine. If these two sensors are sending information, okay, we can handle. There is no problem of network aspect exactly. But just observe, if we are having 1,000 sensors, okay, all 1,000 are sending the information 24/7 exactly. This will be transferred to M2 fog exactly. Here, the congestion may occur. Okay, that congestion we are calling it as network bottleneck. Okay, bottleneck means what? See, bottle size will be more, but the output discharge point will be less exactly, right? The diameter of the bottle may be more. Okay, when we are comparing it to the diameter of the passage from where we are retrieving the water or a cooling. Is it right? Okay, so that situation we are calling it as a bottleneck. Means we'll be having a bulk of information, but the discharge will be less exactly. Such things should not happen. So for that, what we need to do is see slow analytics in the cloud. Okay, that is going to lead the slow analytics. Means whichever the out of 100 GB of information, see 100 sensors we are having, feel that. Okay, per day 100 GB of information we are going to get, means per sensor 1 GB. Okay, then cloud should analyze out of 100 GB, which is essential exactly, which is must. So the cloud will face the slow in the analytics exactly. That will lead us to the face lots of problem in the real environment exactly. Such things should not happen. So whenever we are receiving such type of information like these sensors, okay, as I match my example, see they are sending 1 GB of information per day. So that will be transferred to where exactly edge. So here 25% of data should be filtered. Okay. Then later in the mist level also 25% should be filtered. Then later in the fog level of also 25% should be filtered. See, I'm just taking a rough figure. It is not compulsory like it should process 25% over there. No, for an example, I am considering. Then only 25% of information should be processed by the cloud exactly. Is it right? Then the hectic or the bottleneck condition for the cloud will be reduced. Okay, so this is how we are dealing with massive volume of data generated. Okay, then support for legacy device. IoT network comprises a collection of modern IP capable endpoints, okay, as well as legacy. As I mentioned, that tunneling process, okay, that is what regarding, okay, non-IP devices that rely on serial protocol. Okay, so digital transformation is a long process, and the IoT network needs to support protocol tunneling mechanism to support legacy protocols. So if you are using any old version of the protocol, if any device is using old version of the protocol, then we need to go for tunneling procedure exactly same as usual. Okay, the need of data to be analyzed. Okay, the need for data to be analyzed in real time exactly. Okay, so this is here what I was discussing, slow analytics. Okay, what is this exactly? See, here we see. IT network perform scheduled batch processing of data. IoT data need to be analyzed and represented in real time exactly. So when it comes for IT network, okay, the data will be available in server exactly. See, if the developer is busy today, okay, he may observe or he may utilize the data in the next day. Okay. But such thing, if we perform in IoT, then we have to face some huge losses. Okay, remember. So such thing should not happen. So the data, whatever we are receiving, that should be processed, okay, in real time fashion. Remember this. Okay. So then comparing IoT architectures, okay. So in the past several years, architecture standards and framework have emerged to address the challenges or challenge of designing massive scale IoT network. Okay, the foundational concept in all these architecture is supporting data, then process the data and the function that endpoint device perform. Okay, so these are what some some architectural requirement exactly. So here we'll be discussing about the older version of IoT architecture. Okay, like machine to machine, we are calling it as then IoT World Forum. Okay, so these are the two different architecture which was designed first. Later, okay, after this, we came to a conclusion like a simple architecture. Okay, one architecture we have. Okay, that will be discussed in further classes in one. Okay, not in next video. So in next video, we will be discussing about these two architecture, like one MTM. Okay, see just like two of the best known architecture are those supported by one MTM architecture, and the second one will be the IoT World Forum. The IoT World Forum we are calling this. Okay, means like one MTM. Okay, means machine to machine communication we need to establish. But for that, okay, we had lots of architecture. But what the European institute, what they did, they came across with a proposed architecture. Okay, that we are calling this one MTM. Okay, means one machine to machine architecture. Okay, that is good for machine to machine communication exactly. And another one is the IoT World Forum. Okay, so this is like you know about OSI model, right? Okay, network architecture, OSI model. Okay, like application layer, network layer, session layer, transport layer, such type of layers will be deployed in over here. Okay, so each and every layer will be having its own contribution. Okay, so based on that, we'll be having the result exactly. So regarding these two architecture, we will discuss in the next lecture. Okay, later we'll go for the original architecture of IoT exactly. Okay, so this is it for now, students. So we'll meet with next video. Thank you.